Alright, so in this module we're going to take care of the half 13 threaded hole on the back side of this workpiece. So we'll do that in the milling machine, and we'll use a carbide drill to drill this, and then we'll use a thread mill, a single lead thread mill to cut this. So again, not the only way to do it, but I figure that you know, especially for a laptop, it will give people experience not only starting to work with carbide drills through spindle coolant and then thread milling. So we need to do a new machine group here, so a new machine group for the mill. And then once you do that, okay, the other option instead of doing that way is you can delete, and you could actually go into machine, mill, and pick what you want, and that'll also put another machine group in, and it'll save you from having to replace or select a machine. So another way to do it. What I would do now is I'm just going to do initial stock, or just stock in this case, because it's only going to be one stock model, and I am not going to bother filling this hole. I'm just going to leave it. So I'll go to stock model, and model, select the part, 3 clicks, end selection, turn the stock plane off, and I'm just going to green check. There's our stock model, just a reference in simulation. I would also separate the machine groups now as lathe and mill. And then I'll do a new toolpath group up here this way. And now I'll rename this hole operations. Something along those lines. Okay. Last thing I'll do before we transition is I will go to planes and do a new dynamic plane. I'll stick it to this surface and then transition or translate it over to the center of the bore. Make sure it's 0 G54 and then hit green check, and it's plain is fine. It's not worth renaming right now. Now pay attention to the instructions in the module. I may or may not have you create soft jaws and put the vise in, all that, but you should be able to do that by now. So I'm not going to waste your time showing you all how to do that. So you should be able to create soft jaws that would hold this workpiece on this diameter, and etc. So let's transition here, and we'll get into a little bit of drilling. It's going to be pretty much the same, except for I'll talk about carbide tooling. Alright, so the diameter of this hole per the model is 421 thousandths and 9/10. The spec for a class 2 half 13 thread is anywhere between 417 and 434, so that'll work for us. So we'll go with that, whatever size is close to the the drill bit sizes available, and then we'll end up going into a simple drill operation. Select that geometry and hit green check. Now the tool, I'm going to go to select library tool, and there I already had one, but again, if you go to the filter, search for it, green check, 2764 is what we want. Call it tool 1, and let's take a look here. I'm going to open up HSM Advisor, and I'm going to select a gyro twist tool. That's carbide. Tip diameter is going to be 0.421. The depth of this hole, we'll go back into Mastercam, and if we get in here and right click and analyze entity properties and select that circle, the depth of the hole looks like 1.5 inches. So we'll go back into HSM Advisor and we'll go 1.5. Now there's going to be no pecking, okay? That's not good for carbide drills. You want to make sure you can. I've seen people do it, but you're better off just going. You have to use through spindle coolant to get away with that. Now, look how aggressive the speeds and feeds are. It's moving. So, what I recommend is reducing this in a learning environment by 50% proportionally each speed and feed. That's still fast, but that is what I want you to do. We'll see how it cuts, but I don't want you to go full 100% for your first time potentially using a carbide drill, because that's moving, and that is, you'll break something by the time you stop that. Even at 50%, it's moving pretty good. So that's where we'll leave it. So we're looking at a 510 surface footage and a 6 thou chip load. So we'll go into here. One thing you want to change first is make sure it's 1 flute, because this does not. This is it'll calculate in inches per minute. So if you type in the wrong variables and it's 2 flute, it'll multiply. You'll be going twice as fast. So we want to go about 5.5, I think it was, for 6.5. Sorry. And then we'll end up going for surface footage 5.15. Double check that. 5.10. Okay, 6.5, so it should be around 30 inches a minute. 29.6, that's good. So that's good for this drill. Make sure for your cycle that you're doing simple G81, no pecking. Linking parameters, we'll go to the depth here. And then for tip compensation, we'll break the round to 0 just to make sure that the full diameter goes to 1.5 inches. Everything else is going to be the same except for coolant. Make sure you go to through tool. Recheck. And it's not going to look any different in Mastercam. It's not going to be anything impressive in here. What's going to be impressive is when you go running the machine. You know, if you got through spindle coolant, they work really well. But the problem is they're a little more money, and if you break them, if they're they can be very difficult to get out. So just realize that you save a lot of time not having a peck drill. So there's our drilling operation. Okay, and I'll transition here, and we'll come back in and create a thread mill tool and do a little thread milling. All right, so we need to do a thread mill operation, and in the shop I have their single pitch, or not single pitch, but they're like single fluted, I guess you could say, thread mills. I forget the name off the top of my head, but basically they can cut multiple pitches. It's not like an indexable thread mill or a, you know, like a 12 tooth thread mill where the pitch is fixed. This is not. I'll show you. We'll draw the tool quick, and I'll show you what I'm talking about. And I do this because not only do you get the most motion out of them for practice, but we can do different pitches with them. So let's go into our tool paths, and we'll go down here into thread mill, and we're going to select that hole again. And let's go to tool, and then I'm going to go right click and create tool. Go to thread mill, and here are the specs. So this tool is designed for 1/2-13 and other threads that are slightly less than that. Okay, you gotta think of these as the same as a ID threading tool with lathe, same kind of idea. So we're gonna go with 13 threads per inch, and again, there's like a fixed pitch thread mill, what it would look like. Ours aren't like that. Ours are gonna look something like this. Outside diameter is 0.350 on these. The overall length on these is 3.5 inches, and the cutting length is going to be 1 divided by 13. So it's 1 profile. Okay, 1 full thread form. The shoulder length is 1.575. Shoulder diameter is 1/4 inch. The shank diameter is 1/2 inch. Okay, and we'll taper down. So that's sort of what our tool looks like. Okay. And that'll work for us. Finalize properties, 3.5 thread mills fine, tool 2 is fine. There are 4 flutes on it. It is carbide. We'll hit finish, and there is our thread mill. Now for speeds and feeds, you can get them at HSM Advisor. If you go down to the bottom, there's thread mill, and I do depth of cut, width of cut as the same for our case because it is not. We are doing we're sort of like single point threading with the mill, if that makes sense. So depth of cut and width of cut are going to be the depth of thread, which is something like, remember correctly, it's like 35,000, something like that. So we'll go like, let's say 0.040 just to give us ballpark numbers. And the major diameter is 1/2 inch. Okay, and then notice it's moving. So again, cut them down. So we'll go 612 surface footage at a 6/10 chip load. So I think I said 512 or 612. I always forget. 612. And let's go a 6/10 surface footage. So that's good for us. So 16 inches per minute is what this came up with. 12.57. So let's make sure we get that right. 4 flutes, or 4 cutting teeth, 5.7 for our chip. So that works for us. 15 inches per minute. 12. Let me double check my number of flutes here. Make sure I got that right. 4. That's correct. Finish. So let's see. Make sure I'm just double checking my speeds and feeds because you got to watch out for. Oh, that's why. 0.35. That makes more sense. You got to watch out with these because it's the same idea as helix boring, where the outside of the cutter is actually moving faster than the programmed feed rate. So you really need to pay attention, not go too fast with these. you know, there's a quick formula you could do, but I use HM Advisor a lot. So you just got to be careful of that. So we should end up with a service footage of 602 because I did not put in the right size of cutter, and a 9/10 chip load. And we get 23.65 and 6,500. That's correct. So that's what we're looking for. And that was my fault. I did not have the tip diameter right. That was still the 421 from the drill. So we're good there. Let's get into cut parameters. There's one active tooth. This is a good picture of an indexable thread mill with a fixed pitch. We only have one active tooth on our cutter. The thread pitch is, again, 1 divided by 13 for half 13. Okay, so 0.76923 is correct. This is an ID thread. We're going to override the specifications. The major diameter, in our case, is going to be 0.5. The minor diameter is 0.421. We're going to go from top to bottom. I know it's conventional milling, and we usually go from bottom to top, but it is less intimidating the first time you do this to start in and thread down. It is a right-hand thread. Lead in, lead out, we'll leave default. Multi-passes, we really probably don't need in aluminum, but I'm going to turn them on anyway just to show you how this works. I'm going to end up going like 7 passes at 10 thousandths of rip. Okay, just work our way in nice and easy. Not a big, reason to do that, but I think I do that a lot on parts, especially if it's like stainless and it's only one flute tool, because I want the tool to last throughout the job. I think I get a cleaner thread that way. Now, if I'm using an indexable cutter or a fixed pitch cutter, then I may not do that. You can do it 2 passes maybe. Depends on what the size of the thread and things like that, and what the material is. Lots of variables here. So this will give us some good motion and hopefully not wear out the thread mills. The thread depth. Now, I forget what the drawing said. I don't have it open right now, but I'm just going to go absolute for all of these. And we'll go 2 inches here. 0.1 on the retract. Feed plane's fine. I think it was like 1 inch minimum, so we'll go 1.2. Should be fine there. Minus 1.2. And as far as everything else, we'll turn flood coolant on. Plane should be fine. That's it for now. So let's hit green, check, and you'll see our toolpath. Okay. One of the things I like to do with thread mill is go to top view, and I will go to down in the lower right. You can make the model transparent. I will backplot this operation, and using the S and B icons, I will watch the yellow go in, the yellow of the edge of the cutter. Or you could also go to front view and watch this go. So there we are, and you'll see we're taking a nice easy time in. You'll see you can gauge your cuts that way. It works its way in. Alright, so there's our last pass. Looking at it here. There we go. So you see that's full depth. Okay. And it works its way down. So let's go ahead and we can look at both these operations and verify. So stock model 1 is good for us. We'll go into verify. There we go. So the drilling operation is not a big deal. Nothing exciting there. And let's take a look at the thread mill. So we'll slow it down. And I'll just hit S and work my way through. There we go. So pause it and go back, and you can watch it work. But I'll go back again and just reset this. You don't really need to do the drill op either, if you just want to go through the thread mill. So there we are. So it works its way in. It cuts a little bit. That's perfect. And sometimes what I'll do is I'll actually do a 1 inch depth of threads, and I'll count the pitch. Just to double check. This is just another thing I do sometimes. I'm worried about it. I usually comp these at the machine. Comp the tool to cut big by like 10 thou just to make sure you don't go undersized. We'll be checking this with a go no go gauge. Now I'm just holding S and going through. You see, we're taking our time. Not a big deal. I just don't think it's worth. These tools are kind of expensive, so I don't want to risk breaking them. Again, we'll slow down to hit play at this point. we are. So we got plenty of clearance down here. Thread mill looks pretty good. I don't see any issues. Okay, one thing I do sometimes is I'll take the thread mill and I'll do a 2D chamfer around this to get rid of the lead-in. That's up to you if you like to do that. Again, you should be able to know that by now. I would do that first and then thread mill. Same I did in the lathe. I would do the same thing on the lathe. You prep the chamfer to lead into the thread and then thread. It'll avoid this burr here. But that's up to you. I'm not going to worry about that. You should be able to do a chamfer by now. This is just trying to keep a short video on thread milling. So there's our specs. Okay. That's really it for this one. So there's our drill and thread mill. On that other part, and again, make sure you read the written instructions in this module and double check the drawing for the depth. I thought it was a 1-inch minimum, but again, you can change that quick. So make sure you pause by the thread mill specs. If you have any questions on that, let me know. And then thanks for watching.